The same spiral appears in a galaxy and a seashell. This is not a coincidence. It is a clue. Our universe runs on a hidden blueprint, a stunningly small set of patterns and rules that repeat at every scale, from the quantum to the cosmic. By the end of this journey, you will see reality with a new lens, one that reveals a cosmos of breathtaking order and interconnection. Why does the same shape govern a hurricane, a sunflower, and the galaxy you call home? What does it mean that the branching of your veins mirrors the branching of lightning and rivers? We will decode the evidence written into the fabric of everything. What pattern in nature has always felt strangely significant to you? Look up on a clear night, and you might see a faint, misty band of light arching across the sky. That is the edge of our home, the Milky Way, a colossal spiral of hundreds of billions of stars. It is a shape of staggering power and grace, a cosmic whirlpool sculpted by gravity over billions of years. Yet, this exact same elegant curve appears in the most humble of places. Watch a vine as it reaches for sunlight, its new growth curling into a tight spiral. Watch water swirl down a drain, forming a miniature vortex. Even the seeds in the center of a sunflower are arranged in an intricate spiral pattern, a design of breathtaking precision. From the largest structures in the universe to the smallest growth in your garden, the spiral is a universal signature. This is not a random artistic choice by nature. Physicists tell us it is the most efficient solution to a universal problem. When a fluid, whether it is an ocean of interstellar gas or the water in your sink, rotates and contracts, conservation of angular momentum forces it into this spiral form. It is the path of least resistance, the shape that allows for the most stable and energy-efficient transfer of motion. The spiral is nature's way of organizing chaos into order, of packing material tightly while allowing for dynamic flow. In the sunflower, the spiral allows the plant to pack the maximum number of seeds into the smallest space, following a mathematical rule known as the Fibonacci sequence. Each new seed is placed at a precise golden angle from the last, creating those mesmerizing intersecting spirals we see. This mathematical blueprint, this golden ratio, appears in the curl of a nautilus shell, the arrangement of pinecone scales, and the unfurling of a fern. So why does the universe love this shape? Because it works. The spiral represents a fundamental principle, a pattern optimized by the immutable laws of physics and mathematics. It is a form that emerges whenever growth encounters rotation or when efficiency demands dense packing. This repetition from the galactic to the botanical is our first powerful clue. It tells us that the cosmos is not a collection of random, disconnected phenomena. Instead, it operates on a shared set of instructions, a preference for certain forms that simply make sense no matter the scale. The spiral is a whisper of a deeper order, a single thread in a vast tapestry of repeating patterns. If this shape is a universal solution for motion and growth, what other blueprints might be hidden in plain sight, governing the very structure of reality itself? The spiral shows us a universe in motion, a cosmos that whirls and grows. But what about the structures that hold it all together? For that, we find a different geometric signature, one of stillness and strength. Look at a honeycomb. Each tiny cell is a perfect hexagon, a six-sided chamber of wax. This is not an artistic choice by the bees. It is engineering. The hexagon allows them to build a storage grid that uses the least possible wax to hold the most possible honey. There are no gaps, no wasted space. The walls are shared, creating a structure of incredible efficiency and resilience. This same pattern of interlocking hexagons appears in some of Earth's most ancient stone. The Giant's Causeway in Ireland is a landscape of towering basalt columns. each with a hexagonal cross-section. They formed not from intelligence, but from physics. As a thick lava flow cooled and contracted, it cracked, and the stresses within the rock naturally resolved into this hexagonal fracture pattern. It is the most stable way to divide an area under tension. And then we look beyond our world. At Saturn's North Pole, a storm rages unlike any other in our solar system. A colossal, persistent hexagon, wider than 2 Earths, etches itself into the gas giant's atmosphere. This is a jet stream, a swirling river of wind, somehow locked into a geometric form for decades. Scientists believe it emerges from the complex fluid dynamics of a spinning planet, a natural pattern that arises from the mathematics of rotation and shear. From the microscopic scale of a bee's eye, which is also composed of hexagonal lenses, to the planetary scale of a gas giant storm, this 6-sided shape emerges. It is the universe's preferred architecture for packing things tightly and distributing force evenly. Whether in cooling rock, organizing insects, or turbulent atmospheres, the hexagon represents a solution to a fundamental problem: how to build stable, efficient structures with no architect, only the relentless pressure of physical law. This pattern whispers that the same principles of stability govern a beehive and a planet. So if shapes like the spiral and hexagon are universal blueprints for motion and structure, what pattern might govern the very flow of energy and information itself? A single bolt of lightning carves a jagged, brilliant path through a dark sky. From space, the veins of a river delta spread like a living tree across a continent. Inside you, right now, the airways in your lungs branch into ever smaller passages to deliver oxygen. These are not just passing resemblances, they are different expressions of the same fundamental command, a pattern so essential it is written into the very logic of distribution. This is the branching pattern, and it solves a universal problem. How do you connect one point to an entire area, or collect from a vast region back to a single source, using the least possible energy and material? Nature's answer is always to branch. A river does not carve a single, straight trench to the ocean. It creates a network of tributaries because that is the most efficient way for water to find its way downhill, eroding the path of least resistance across an entire landscape. A tree does not grow one massive trunk to a single leaf. It branches so that every leaf has access to sunlight and every root tip can seek water and nutrients, maximizing its reach while minimizing the length of each individual pathway. Your circulatory system branches for the same reason, to deliver blood to trillions of cells with a heart that does not have to work impossibly hard. This is not a vague visual theme, it is a precise mathematical convergence. Scientists describe it with fractal geometry, where a similar shape repeats at smaller and smaller scales. Look closely at a single twig and you see the pattern of the whole tree. Look at a minor tributary and you see the shape of the entire river system. This self-similarity is the hallmark of a process optimized by physical law. There is even a specific principle known as Murray's law that predicts the exact optimal diameters of branching tubes, whether they are plant stems, blood vessels, or human-designed plumbing systems. The universe, it seems, has a favorite blueprint for building networks. When the task is to spread something out or gather it in, branching is the inevitable, elegant solution. This pattern ties the fury of a storm to the quiet growth of a tree and the silent flow of blood in your veins. It reveals a cosmos where connectivity follows a common, computable rule. If branching is the universe's design for distribution, what invisible, fundamental sculptor is responsible for carving these efficient forms from the formless void in the first place? These breathtaking patterns do not emerge from a void of chance. They are carved into reality by invisible hands, the fundamental forces that govern every particle and every galaxy. Gravity, the great unifier, is the sculptor of the grandest scales. It is the relentless pull that gathers clouds of dust into spinning disks, coaxing them into the majestic spirals of galaxies. It pulls matter equally from all directions, forging stars and planets into near-perfect spheres, the shape that minimizes energy and represents a state of balance. Without gravity's steady hand, there would be no grand architecture, only a formless cosmic mist. But gravity does not work alone. At the atomic and molecular level, the electromagnetic force takes the lead. This is the glue of reality, the attraction between positive and negative charges that binds atoms into molecules. It is electromagnetism that dictates how water molecules connect to form the intricate, six-fold symmetry of a snowflake, no two ever alike, yet all following the same geometric rules. It governs the formation of crystals from the salt on your table to the quartz in the earth, creating repeating lattices of stunning precision. The very structure of every solid object you touch, the chemistry of life itself, is a dance choreographed by this force. Then there are the nuclear forces operating within the hearts of atoms. The strong nuclear force is the unimaginably powerful binder that holds atomic nuclei together against the tremendous force of protons repelling each other. Without this force, no complex atoms would exist. There would be no carbon for life, no iron for blood, no silicon for planets. The weak nuclear force drives processes like radioactive decay, a slow transformation that, over cosmic time, helps forge the heavier elements that seed new stars and worlds. These forces set the stage, creating the stable building blocks that gravity and electromagnetism can then assemble into larger forms. The pattern you see, whether a spiral, a hexagon, or a branching network, is the final signature. It is the visible outcome of a silent battle, a perfect compromise between competing influences. A planet is a sphere because gravity's pull overpowers the strength of the rock. A snowflake is a branching crystal because electromagnetic bonds favor specific angles as water freezes, while atmospheric conditions guide its growth. The shape is a direct physical consequence, a solution written by the laws themselves. So when you see the same form echoed from the quantum world to the cosmic horizon, you are not seeing a mere coincidence. You are witnessing different materials and scales responding to the same set of universal commands. These forces are the tools, and the cosmos is their workshop. If these fundamental laws carve such consistent shapes across reality, what happens when we apply their logic to the very fabric of space and time, to the origins of everything? The jagged edge of a coastline tells a hidden story. Zoom in on any map, from the rugged cliffs of Norway to the intricate bays of Maine, and a strange truth emerges. That large, craggy shape you see from space is not a single smooth line. It is composed of smaller bays and peninsulas, which themselves contain even smaller coves and rocky outcrops. Each level of magnification reveals a roughness that echoes the whole. This property, where a pattern nests inside itself at ever smaller scales, is not just a curious feature of geography. It is a fundamental architectural principle of our reality, known as fractal geometry. A fractal is a shape of infinite complexity, built from the endless repetition of a simple rule. Look at a head of broccoli, break off a single floret, and you are holding a miniature version of the entire vegetable. The branching veins in a leaf mirror the branching of the tree that holds it. A lightning bolt forks into smaller bolts which fork again, creating a terrifyingly beautiful fractal tree of electricity in the sky. This self-similarity is everywhere. The puffy edges of a cumulus cloud, the jagged silhouette of a mountain range against the horizon. The vast, filamentary structure of the cosmic web that connects galaxies across the void, even the incredibly folded surface of the human cerebral cortex, which packs an immense area into a compact space, all display this recursive design. For centuries, these forms were seen as irregular, messy, beyond mathematical description. Then, a mathematician named Benoit Mandelbrot asked a revolutionary question. What if this roughness was not noise, but a signal? What if there was a hidden order within what appeared to be chaos? He developed a new geometry to describe the roughness of nature, coining the term fractal from the Latin word for broken or fractured. His most famous discovery, the Mandelbrot set, is generated by a single, simple equation. Yet when that equation is iterated, calculated over and over again, it produces an image of staggering and infinite complexity. A boundary that is not a smooth line, but an infinitely long, infinitely detailed coastline of mathematical form. You can zoom into its edge forever and never find a smooth, repeating pattern, only more and more intricate, self-similar structures. This was the profound revelation. Nature builds its immense complexity not through endless unique blueprints, but through recursion. It applies the same simple process repeatedly, like a cosmic algorithm. A river carves its main channel by following the path of least resistance. Then, the water in that channel erodes smaller paths, following the same rule, creating tributaries. Those tributaries do the same, creating streams, and so on, down to the tiniest trickle. One rule, applied at different scales, builds an entire watershed. This concept is called scale invariance. It means the pattern has no preferred size. It looks essentially the same whether you are looking at a mile or a millimeter. This is a powerful clue that the universe's blueprint is not just mathematical but algorithmic. It suggests a cosmos that builds itself by running simple programs, where the output of one step becomes the input for the next, generating the rich tapestry we see. The fractal is nature's way of creating maximum surface area, maximum connectivity, and breathtaking complexity from minimal instruction. It is the signature of a process, not a pre-drawn plan. So if the universe operates like a recursive algorithm, generating infinite variety from simple rules, are there specific numbers, mathematical constants, that act as the core code for this entire cosmic program? There is a number that seems to whisper from the heart of a flower and the curve of a galaxy. It is approximately 1.618, known as the golden ratio, and for thousands of years it has captivated the human mind as a signature of divine or natural perfection. You can find its proportions in the architectural harmony of the Parthenon and in the balanced geometry of Leonardo da Vinci's Vitruvian Man. But to see it in its purest, most dynamic form, look at a nautilus shell. Its chambered interior expands in a perfect logarithmic spiral, each new section growing by a factor of phi, the golden ratio, creating that iconic, elegant curve. This is not an artist's imposition, but a growth pattern written into the biology of the organism. The same mathematical rule governs the arrangement of leaves around a stem, a pattern called phyllotaxis. Why do leaves spiral around a stalk instead of stacking directly on top of each other? Because this golden arrangement ensures every leaf gets maximum exposure to sunlight and rain, minimizing shadow on the leaves below. It is nature's most efficient packing algorithm for sequential growth. You see it clearly in the face of a sunflower. The seeds are not scattered randomly. They are packed in two sets of interlocking spirals, one curving clockwise, the other counterclockwise. Count those spirals, and you will almost always find two consecutive numbers from the Fibonacci sequence, like 34 and 55, or 55 and 89. This sequence, where each number is the sum of the two before it, has an intimate, surprising relationship with the golden ratio. As the sequence progresses, the ratio between successive Fibonacci numbers gets closer and closer to phi. 1, 1, 2, 3, 5, 8, 13, 21, 34. Divide 34 by 21 and you get about 1.619. This is not magic but mathematics. In any system that grows by adding new elements based on the state of previous ones, this ratio naturally emerges as the most stable, space-filling arrangement. It is the solution to a simple optimization problem written into the fabric of life itself. So is the golden ratio a fundamental constant of the universe, like the speed of light. The debate among scientists is nuanced. Its appearance in art and architecture is often a conscious human application of an aesthetically pleasing proportion. But its spontaneous emergence in biology, in pine cones, pineapples, and flower petals, points to something deeper. It is a naturally emerging solution, a beautiful mathematical attractor that growth processes tend to fall into because it simply works best. Whether a fundamental rule or a frequent byproduct of efficient systems, its recurrence is a profound clue. It tells us that the elegance we perceive in a seashell or a sunflower is not merely decorative but computational. It is the visible output of a simple, iterative algorithm, a piece of code in nature's programming language that builds breathtaking complexity from a minimalist rule. This mathematical elegance does not stop with shapes and growth. It extends to the very constants that define the forces holding our reality together, numbers so precise that if they were even slightly different, nothing we know would exist at all. The mathematical beauty of a seashell or a sunflower hints at a deeper, more rigid framework underpinning reality. These are not just patterns of growth, but patterns of possibility, and their very existence depends on a set of unyielding cosmic rules. Think of the universe as an intricate board game. The patterns we see, the spirals and branches and fractals, are the possible moves, the beautiful strategies that emerge from play. But the game itself is defined by its rulebook, a collection of fixed, unchanging numbers known as the fundamental constants. These are the speed of light, the strength of gravity, the charge of an electron. They are the numerical settings of reality, dials that were set at the dawn of time and have not budged since. Their values are not derived from any deeper theory. They are simply the numbers we measure. And their precision is nothing short of terrifying. Imagine tuning a radio dial with unimaginable care. If the gravitational constant were even a tiny fraction stronger, the universe would have collapsed back on itself instantly after the Big Bang. If it were a fraction weaker, matter would never have clumped into stars and galaxies. If the strong nuclear force which glues atomic nuclei together were just a few percent different, hydrogen would be the only element that could exist. There would be no carbon, no oxygen, no chemistry, and certainly no life. One of the most intriguing of these numbers is the fine structure constant. It is a pure, dimensionless number that governs the strength of the electromagnetic force. This single value dictates how tightly electrons are bound to an atomic nucleus. Change it ever so slightly, and the very architecture of atoms changes. Chemical bonds become impossible, or alternatively, stars burn their fuel in seconds. The fact that our universe possesses this exact suite of constants, this precise recipe that allows for stable atoms, long-lived stars, complex molecules, and ultimately the patterns we admire, is a profound enigma. Physicists call this the fine-tuning problem. Why is the cosmos so hospitable to complexity? Some propose a staggering answer: the multiverse. In this view, our universe is but one bubble in a vast cosmic foam, each with its own random set of physical constants. In most of those bubbles, the numbers are wrong and nothing interesting happens. We simply find ourselves in the rare one where the dials were set just right for patterns, for planets, for observers. Whether our universe is uniquely tuned or one of countless statistical outcomes, the result is the same for us. These constants provide the stable, unchanging rulebook. They are the non-negotiable laws of physics that every particle, every force must obey. It is from this rigid, reliable foundation that the fluid beauty of patterns can reliably emerge. The constants set the stage, and on that stage, the dance of matter and energy performs its endless, patterned improvisation. So with this immutable rulebook in place, What magnificent structures does the universe build when it has entire galaxies to play with? This grand cosmic architecture, the web of galaxies, finds a startling echo in the most intimate space we know, the human mind. The branching filaments of the cosmic web, viewed from a certain perspective, bear an uncanny resemblance to a neural network, the interconnected web of 100 billion neurons in the human brain. One is a map of dark matter and galaxies sculpted by gravity across billions of light years. The other is a map of thoughts and memories, sculpted by electrical impulses within a single skull. This visual similarity is profound, but it is not a sign that the universe is a brain or that we are living inside a mind. Instead, it points to a deeper, more fundamental truth. Both systems are networks optimized for efficiency. In the cosmos, the cosmic web is the most efficient structure for matter to cluster under the relentless pull of gravity, forming highways of galaxies. In the brain, the neural network is the most efficient structure for information to travel, forming pathways of thought. They are both expressions of a universal principle that complex systems, whether made of stars or synapses, tend to self-organize into similar, web-like patterns to facilitate flow and connection. This pattern emerged from the faintest of beginnings. In the first fleeting moments after the Big Bang, the universe was not perfectly smooth. It was imprinted with microscopic quantum fluctuations, tiny ripples in the fabric of space-time itself. For billions of years, gravity acted as an amplifier. It gently tugged matter toward these slightly denser regions. Ordinary matter, the stuff of stars and planets, flowed along the gravitational contours shaped by the invisible scaffolding of dark matter. Over cosmic time, this process wove the primordial ripples into the vast, luminous tapestry we see today, a fractal structure where clusters of galaxies are connected by filaments and separated by immense, empty voids. This is the universe's largest possible pattern, and it was written by the same simple rule that governs a dripping faucet or a gathering crowd, the rule of attraction. What happens then when we reverse our gaze, shrinking our perspective from the largest structures imaginable down to the very smallest? But to find the source of this cosmic architecture, we must journey inward, past galaxies and planets, past cells and molecules, to the very foundation of all matter. At the quantum scale, the familiar rules of our world dissolve into a realm of probability and wave-like behavior. Here, the elegant orbits of planets give way to something far stranger. An electron does not circle an atomic nucleus like a tiny planet. Instead, it exists as a cloud of potential, a haze of probability described by a mathematical shape called an orbital. These orbitals are not random. They are exquisite, symmetrical solutions to the most important equation in quantum mechanics, the Schrödinger equation. Some are perfect spheres enveloping the nucleus in a fuzzy shell. Others are shaped like dumbbells or even intricate three-leaf clovers. These are the fundamental building blocks of atomic structure, the pure mathematical forms that matter takes at its most basic level. This quantum order does not stop with single atoms. It builds upward, creating the entire periodic table of elements, one of humanity's greatest discoveries of pattern. Dmitri Mendeleev did not just list elements randomly. He arranged them in rows and columns based on their repeating chemical properties. Why do these properties repeat? Because the arrangement of electrons in those quantum orbitals follows a predictable periodic pattern. An atom with one electron in its outer shell behaves in a certain way. Add more electrons following the quantum rules and the properties change, but then, after a specific number, they begin to echo the earlier behaviors. This periodicity is the direct result of the underlying quantum architecture. The entire dazzling diversity of chemistry, from the inertness of neon to the explosive reactivity of sodium, is orchestrated by the filling of these symmetrical probability clouds. So when you look at the branching pattern of a tree or the spiral of a galaxy, you are seeing a grand chain of causality. the quantum world, governed by waves and symmetries encoded in mathematical equations, provides the stable atoms. Those atoms bond following electromagnetic rules, forming molecules and crystals. Gravity and other forces then assemble those materials into the larger structures that echo the foundational forms. The cloverleaf shape of a quantum orbital and the spiral arm of a galaxy are distant relatives, connected by an unbroken thread of physical law. This reveals a cosmos of breathtaking coherence, where the same language of mathematics describes the behavior of a single electron and the evolution of a star cluster. If the quantum realm provides these perfect, symmetrical building blocks, how does such pristine order give rise to the messy, adaptive, and endlessly creative phenomenon we call life? The quantum world provides the perfect building blocks, but life is the universe's masterpiece of improvisation. From those symmetrical atoms, our planet wove a tapestry of staggering complexity, yet even here, the same patterns emerge with stunning consistency. Consider the challenge of moving through a dense medium like water. A shark, a dolphin, and an extinct ichthyos are not closely related. One is a fish, one is a mammal, and one was a reptile. Yet all three evolved bodies with nearly identical streamlined torpedo shapes. This is not a shared ancestry, but a shared physics. The laws of fluid dynamics dictate that this particular form minimizes drag and maximizes speed. Evolution, acting as a relentless problem solver, discovered this optimal solution independently multiple times. This phenomenon is called convergent evolution, and it is a powerful testament to the universe's limited menu of successful designs. The same story unfolds in the air. The wings of a bird, a bat, and a pterosaur all converged on a similar aerodynamic blueprint because the physics of lift and thrust only allows for so many viable solutions. Even something as intricate as the eye, that remarkable organ of sight, evolved not once but independently in many different lineages. From the compound eye of an insect to the camera eye of an octopus or a human, nature repeatedly arrived at a lens-based system to focus light, because the chemistry of light-sensitive proteins and the optics of refraction point toward that same elegant answer. Life is not inventing from an infinite palette. It is exploring a finite landscape of possibilities, discovering the same peaks of efficiency again and again because the terrain itself, shaped by physics and chemistry, guides the journey. Even the very code of life whispers this truth. The DNA molecule, the instruction manual for every living thing on Earth, is a double helix, a spiral. This is not an accident. It is the most stable and efficient way to pack a long, fragile strand of information inside a cell, while still allowing it to be easily copied and read. The spiral, that universal signature of growth and motion, is written into our very essence. So what does this mean for life beyond our world? If the universe truly operates on a common blueprint, if physics and chemistry are the same everywhere, then the challenges of survival on another planet, in an ocean or an atmosphere, would be solved by the same principles. An alien creature swimming in a subsurface sea would likely be streamlined. A flying organism in a thick atmosphere would likely have wings. They might be built from different molecules, their biochemistry utterly foreign, but their forms and functions could feel hauntingly familiar. They would be other explorers climbing the same mountains of efficiency in an alien landscape. This convergence from the biological to the cosmic points toward a profound idea that the universe is not just a place of matter and energy, but a processor of information, constantly finding and refining the most effective solutions. The repetition of patterns is a message, and that message is written in a universal language, information. At its core, every spiral, every branching network, every fractal coastline is a way to encode order. This is not just a poetic idea, it is a rigorous science called information theory, pioneered by a man named Claude Shannon. He gave us the tools to measure information, to understand it as a fundamental quantity like mass or energy. From this perspective, the laws of physics are not just equations, they are algorithms. They are the processing rules that take the initial conditions of the universe, the raw data of the Big Bang, and transform it step by step into the breathtaking complexity we see today. In a very real sense, the cosmos can be thought of as a vast computer running a single, elegant program defined by these physical laws. The patterns we observe, from the quantum to the cosmic, are the output of that computation. This explains a profound mystery. How can simple rules generate such immense richness? Consider a digital simulation called cellular automata. Imagine a grid of squares that can be either on or off. You start with a random row, then apply a basic rule, like a cell turns on if exactly one of its two neighbors was on in the previous step. You then apply that same rule to the next row and the next, iterating it over and over. From this trivial starting point and this minimalist instruction, astonishingly intricate, lifelike patterns can emerge, full of triangles, waves, and complex structures that seem to have a life of their own. This is a direct analogy for our universe. The fundamental forces and constants are the simple, universal rules. The quantum fluctuations of the early cosmos were the initial random row. And the relentless iteration of those rules over billions of years, the cosmic program running, generated galaxies, planets, and pine cones. The eerie repetition of patterns across scales, from the branching of a river to the branching of the cosmic web, could be a signature of this consistent computational logic. It suggests the universe is not just behaving randomly, but processing information in the most efficient way possible, finding optimal solutions like the spiral or the hexagon again and again. This view bridges a profound gap. It connects the tangible, physical world of stars and seashells to the abstract world of logic and data. It proposes that at the foundation of reality lies not just matter, but meaning, a kind of cosmic code being executed. And this leads to a fascinating, inevitable question. If the universe is a grand computation generating patterns, what happens when a pattern within that universe, the human mind, becomes aware of the code? That same drive to find the code is woven into the fabric of our own minds. We are, by our very nature, exquisite pattern recognition machines. For our ancient ancestors, survival depended on it. Spotting the subtle pattern of a predator's stripes in the dappled jungle light, predicting the seasonal pattern of rains by the movement of stars, recognizing the repeated shape of an edible fruit, these were not intellectual exercises. They were matters of life and death. Our brains evolved to constantly sift through the noise of the world, seeking signals, connections, and predictable sequences. This deep-seated tendency has a name, Apophenia, the human propensity to perceive meaningful patterns within random data. It is why we see a face in the craters of the moon, a bear in the scattered stars of Ursa Major, or the Virgin Mary in a piece of toast. Our minds are so eager for order that they sometimes impose it where none exists. Yet this very same capacity, this sometimes overzealous pattern detector, is also our greatest gift. It is the engine of all discovery. For every false pattern, like seeing shapes in clouds, there is a genuine, profound connection waiting to be found. It was this drive that led early astronomers to connect the dots of stars into constellations, not just as myths, but as maps. It is this drive that allows a scientist to look at a jumble of data points and discern the elegant curve of a natural law hidden within. Our perception walks a fascinating line. It can create illusion, but it is also the only tool we have to perceive reality's true design. And often, we create from a place of deep, intuitive understanding long before we can formally prove it. Look at the art and architecture across human history. The mandala, a spiritual symbol in Hinduism and Buddhism, is a concentric diagram of stunning geometric symmetry, a fractal representation of the cosmos emanating from a central point. The rhythmic patterns in music, the repeating sequences of notes and beats, tap into something fundamental about waves and resonance. The soaring arches and precise proportions of a Gothic cathedral often unconsciously incorporate the golden ratio, creating spaces that feel inherently harmonious and uplifting. These creations were not the result of physicists calculating equations. They emerged from an intuitive human resonance with the underlying order of the world. Artists and builders felt a rightness in these forms, a beauty that seemed to echo a deeper truth. This drive to find and then to create pattern is the very spark of science and philosophy. It is the restless curiosity that pushes us to ask why the apple falls, what the stars are made of, and how life began. Our consciousness, then, is both the seeker and a stunning example of what is being sought. We are a pattern-seeking process born from a universe of patterns, using our pattern-recognizing minds to decode the pattern-generating code from which we arose. This beautiful loop of inquiry is not new. Long before the language of quantum physics or fractal geometry, the wisest of ancient cultures were already speaking in the poetry of these universal truths. These ancient symbols were not idle decoration, but maps of a perceived cosmic order. Across continents, long before the scientific method gave us equations, humanity's spiritual traditions were already drawing the blueprint. In the intricate interlocking circles of the flower of life, carved into ancient Egyptian and global temples, we see a model of creation itself, of how all life emerges from a single source. The Sri Yantra of Hindu tradition is a mesmerizing matrix of interlocking triangles, representing the union of masculine and feminine principles, a geometric meditation on the birth of the universe from a single point. Tibetan monks painstakingly create mandalas from colored sand, concentric circles and squares radiating outward, only to sweep them away in a ritual of impermanence. Each is a symbolic model of the cosmos, from its divine center to its material edges. These were acts of devotion, but also of profound observation. The artists and mystics who designed them were looking at the same world we are, seeing the hexagons in honeycombs, the spirals in shells, the branching in trees. They sensed a hidden harmony, a geometric perfection underpinning the chaos of nature, and they sought to replicate it, to align human spaces and consciousness with that divine architecture. Even the philosopher Plato in ancient Greece proposed that the 5 perfect 3-dimensional shapes, the Platonic solids, were the literal building blocks of the universe. He associated the tetrahedron with fire, the cube with earth, the icosahedron with water, the octahedron with air, and the dodecahedron with the cosmos itself. While we now know atoms and molecules do not take these perfect forms, Plato's intuition was startling. These are the only possible polyhedra whose faces are all identical regular polygons, a finite set of perfect forms emerging from pure mathematics. That such perfection existed in the abstract realm of geometry and seemed to manifest in the natural world was, to him, evidence of a rational, designed cosmos. These traditions, separated by vast distances and centuries, all arrived at the same core realization that geometry is the language of creation. Their explanations were wrapped in the mythology of their time, speaking of gods and primal elements, but their eyes were seeing true patterns. They recognized that certain shapes carried a power, a rightness, that resonated deeply with the structure of reality. This historical pursuit shows our drive to understand universal patterns is not a modern invention, but a fundamental thread of the human story. It is a quest to find our place within a grand design, to build our temples and our philosophies in harmony with the perceived rules of the universe. We now inherit that quest, armed with telescopes and microscopes instead of sacred symbols, but we are answering the same ancient call. And as we map the cosmos with new tools, we find a pattern that governs not just the shape of things, but the very rhythm of existence itself, a universal curve that describes everything from the life of a star to the spread of a rumor. The cosmos breathes in a steady rhythm. Look up at the night sky and you are watching a grand, silent clockwork. The planet you stand on completes a full rotation every 24 hours, giving us day and night. It makes a full journey around our star every 365 days, bringing the cycle of seasons. Our moon waxes and wanes in a monthly cadence, pulling the oceans in a rhythmic tide. These are not isolated events, but expressions of a universal temporal pattern, the cycle, where spatial patterns like spirals and branches show us the universe's shape. Cycles reveal its pulse. They are patterns woven into time itself, repetitions of states and processes that create the stable foundations upon which everything else is built. Your own heart is a perfect example, a muscular pump contracting and relaxing in a lifelong cycle that sustains you. The very cells in your body follow a circadian rhythm, an internal biological cycle tuned to the rotation of Earth, governing when you sleep and wake. On a planetary scale, the water cycle endlessly circulates moisture from ocean to cloud to rain to river and back again, a closed-loop system that cleanses and redistributes this essential substance for life. The carbon cycle moves this fundamental element through the atmosphere, the oceans, living creatures, and the very rocks, maintaining a delicate balance that regulates our climate. These are not just neat processes we observe, they are the engines of sustainability. Without these repeating loops, resources would be used once and lost, and stable, complex systems like a forest or a civilization could never arise. In physics, the principle is everywhere. A pendulum swings back and forth, its arc a perfect demonstration of harmonic motion. Light itself is an electromagnetic wave, a continuous cycle of oscillating fields propagating through space. At the most fundamental level, cycles represent dynamic equilibrium. A system is pushed from a state of balance, and natural forces pull it back, only for inertia to carry it past center again, creating a perpetual, stable rhythm. This temporal pattern may be as essential to the cosmic blueprint as the hexagon or the fractal. It suggests the universe is not just a static sculpture of beautiful shapes, but a dynamic, rhythmic process. Stability is not found in stillness but in balanced motion. The cycle is the universe's way of creating permanence through change, of allowing complexity to flourish within a framework of reliable return. From the orbit of an electron to the billion-year life and transformation of a star, everything is caught in a majestic, nested set of turning wheels. This brings us to perhaps the most profound cycle of all, one that uses repetition not to stay the same, but to generate endless novelty, the pattern we call evolution. Life itself is the most famous story of change, but it is not the only one. The same algorithm that sculpted the hummingbird from single-celled ancestors is at work across the cosmos, in systems with no DNA at all. This is the pattern of evolution, a universal recipe for transformation. It begins with a simple starting point. Then, a source of variation introduces new possibilities, like random mutations in a gene or slight differences in the chemical soup of a primordial cloud. Finally, a selection pressure acts as a filter. In nature, it is environmental fitness. Does this new trait help an organism survive and reproduce? In other systems, the pressure might be gravitational stability, economic efficiency, or simply what works best. Over time, through countless iterations, this simple loop of variation and selection sculpts staggering complexity from humble beginnings. We see it in the life cycle of a star. A vast cloud of hydrogen begins to collapse under its own gravity. Slight density variations within that cloud determine where the first clumps form. The pressure of gravity then selects for a structure that can achieve a stable balance between the inward crush and the outward push of nuclear fusion. The star evolves, fusing lighter elements into heavier ones, until it either settles into a quiet retirement as a white dwarf or explodes in a supernova, seeding the cosmos with the raw materials for planets and life. The star did not have a plan, but it followed a physical algorithm of change. Languages evolve in a strikingly similar way. Words mutate with accents and slang, new terms are coined, and the selection pressure of communication, what is useful, clear, and culturally resonant, determines which variations spread and which fade into obscurity. The English spoken today would be nearly unrecognizable to someone from 1,000 years ago, yet the change was gradual, driven by a constant interplay of innovation and utility. Even technology follows an evolutionary path. Consider the automobile. The earliest models were wildly varied steam-powered, electric, gasoline. Market demands, engineering constraints, and resource availability acted as the selection pressures, gradually favoring the internal combustion engine for decades, until new pressures around sustainability are now favoring electric vehicles once more. Each iteration builds upon the last, with successful variants being replicated and improved. This reveals something profound. Evolution is not merely a biological process. It is a meta-pattern, a fundamental algorithm for discovery that the universe employs wherever there is a system capable of storing information and facing competition. It is how complexity bootstraps itself into existence, finding innovative solutions to the relentless pressures of an ever-changing environment. From the crystalline structure of a mineral forming under specific heat and pressure to the spread of a cultural idea, the same three-part dance repeats: a population of variants, a test, and a replication of the successes. This lens allows us to see a grand continuity, from the first stars igniting in the darkness to the latest app on your phone. They are all products of a cosmic evolutionary process, different expressions of the same pattern of trial, error, and refinement. If this algorithm is so universal, then the grandest story of all, the origin and development of everything we see, must also be its ultimate masterpiece. The grandest evolutionary story is the one that contains all others. It began not with a single cell, but with a single, unimaginable point of pure potential. From that initial singularity, the universe embarked on a journey of transformation, its every step guided by the very blueprint we have been tracing. In the first searing moments after the Big Bang, reality was a nearly smooth, featureless soup of energy and fundamental particles. There was no structure, no form, only a simmering uniformity. Yet, even in that perfect heat, the seeds of all future patterns were already present. Tiny quantum fluctuations, random ripples at the smallest scale, were imprinted on the fabric of the newborn cosmos. These were the first variations in a system about to undergo the most profound selection process of all. The selector was gravity. Over hundreds of millions of years, this weakest but most persistent of forces began to act. It gently tugged matter toward those slightly denser regions, amplifying the faintest whispers of irregularity into shouts. Gas and the mysterious dark matter began to clump, then to collapse, then to spin. From that smooth beginning, the first great pattern emerged, the majestic spiral and elliptical shapes of galaxies. Each galaxy became a stellar nursery, a cradle for the next evolutionary leap. Within these swirling clouds, gravity compressed pockets of hydrogen and helium until the pressure ignited nuclear fusion in their cores. Stars were born. This was a new kind of forge. Inside these blazing crucibles, the simple elements of the early universe were fused into heavier ones: carbon, oxygen, iron, the very building blocks of planets and life. But a star, in its stable middle age, holds these creations prisoner. For the next stage to begin, these new elements needed to be scattered back into the cosmos. That scattering came in the most violent of evolutionary selections, the supernova. A massive star having forged iron in its core can no longer sustain fusion. It collapses catastrophically and then explodes with the brightness of 1 billion suns, seeding the surrounding space with a rich cloud of stardust, a chemical legacy containing every element known to life. This enriched debris, mixed with primordial gas, collapses once more under gravity to form new stars, but now these second-generation stars are surrounded by swirling disks of rocky and metallic material. From these disks, planets coalesce, worlds with iron cores, silicate mantles, and in the fortunate orbital zone we call the habitable belt, liquid water oceans. Each stage in this cosmic evolution sets the precise conditions for the next. Galaxies provide the safe haven for stars. Stars act as the alchemical furnaces. Their explosive deaths provide the raw materials. Planets become the stable laboratories where those materials can mix, cool, and undergo the complex chemistry that might lead to life. This is not a random sequence of events. It is a logical, step-by-step unfolding of potential, written into the laws of physics from the very first moment. The universe's constants and forces created a recipe where increasing complexity was not just possible, but inevitable, given enough time and the right initial conditions. This grand narrative shows the universal blueprint operating across the deepest of timescales, an evolution of form and function that builds worlds from particles and perhaps consciousness from chemistry. To witness the stunning results of this 14 billion-year process, we need look no further than our own celestial neighborhood. Our own solar system is a perfect, detailed model of this cosmic craftsmanship. Look at its architecture and you see a miniature universe obeying the same rules. All 8 planets orbit the Sun in nearly the same flat plane, like marbles rolling on a vast, invisible table. They also travel in the same direction, counterclockwise as viewed from above. This elegant alignment is not a lucky accident. It is the direct inheritance of the solar system's birth. The Sun and planets formed from a single, spinning cloud of gas and dust, the solar nebula. As this cloud collapsed under gravity, it spun faster, flattening into a disk, just as a ball of pizza dough flattens into a wide circle when spun. The planets coalesced from this disk, inheriting its rotation, which is why they all march in the same orderly parade today. This is conservation of angular momentum in action, a fundamental law that sculpts spirals and disks across the cosmos. Even the spacing of the planets shows a curious pattern, a rough mathematical relationship once noted by astronomers Titius and Bode. While not a perfect law, it hints at the subtle gravitational nudges and resonances that can organize a system over time. Look closer at the individual members of this family. Many of the major moons, like our own, show a phenomenon called synchronous rotation. They spin on their axis in exactly the same time it takes to orbit their planet, so they forever keep the same face turned inward, locked in a gravitational embrace. This tidal locking is a predictable pattern, a final, stable state for many orbiting bodies. The gas giants Jupiter, Saturn, Uranus, and Neptune all boast magnificent ring systems, delicate halos of ice and dust. While Saturns are the most glorious, the presence of rings around all 4 points to a common process, likely the breakup of moons or other bodies that wandered too close and were torn apart by tidal forces. And within their thick atmospheres, we see another familiar signature, the banded pattern of jet streams and swirling storm systems, like Jupiter's great red spot, a hurricane larger than Earth that has raged for centuries. These are all predictable outcomes, not coincidences. They are the inevitable results of accretion, gravity, fluid dynamics, and the conservation of that original spin, playing out with local ingredients. By studying our own celestial backyard in exquisite detail, we have a front row seat to watch how universal physical processes create stunning order from primordial chaos. It is a template, and with our modern telescopes, we now see similar disks, similar planetary arrangements, and similar patterns beginning to form around other stars. This local evidence is powerful. It tells us our solar system is not a unique oddity, but a standard issue masterpiece built from a universal playbook. And at the heart of so much of this order, from the symmetry of a snowflake to the balanced orbit of a moon, lies a profound and beautiful principle: symmetry itself. A snowflake is a masterpiece of symmetry. Each of its 6 arms is a perfect mirror of the others, an intricate lattice of ice crystals grown from a single speck in a cloud. This radial symmetry is not just beautiful, it is a physical record of the uniform conditions it experienced as it fell through the air. Symmetry is the hidden order, a principle so deep it is woven into the fabric of reality itself. We see it in the bilateral symmetry of our own bodies, a left and right half that mirror each other, a design shared by countless animals for efficient, balanced movement. We see it in the radial symmetry of a daisy or a starfish, where identical parts radiate from a central point, an optimal design for organisms that interact with their environment from all directions. At its core, symmetry means invariance under transformation. If you rotate a perfect circle, it looks the same. If you reflect a butterfly across its center line, its wings match. This is more than a pleasing visual pattern. It is a profound mathematical and physical principle. In fact, the laws of physics themselves are built on symmetry. One of the most powerful ideas in all of science, called Noether's theorem, states that for every continuous symmetry in nature, there is a corresponding conservation law. The fact that the laws of physics do not change from moment to moment, a symmetry in time, leads directly to the conservation of energy. The fact that they are the same in every direction, a symmetry of rotation, leads to the conservation of angular momentum. These are not separate rules, they are 2 sides of the same coin, revealing that the deepest truths of our universe are expressions of balance and invariance. Our most successful theory of particles and forces, the Standard Model, is fundamentally a description of certain exquisite mathematical symmetries, called gauge symmetries, that dictate how particles interact. Symmetry, then, represents the ultimate efficiency and balance, a state of perfect order. Yet, if symmetry were perfect and unbroken, our universe would be a very dull place. A perfectly symmetrical universe would be a featureless soup, uniform in every direction, with no stars, no planets, and certainly no us. The richness of reality comes from broken symmetry. In the earliest moments after the Big Bang, the universe was in a state of extremely high symmetry. As it expanded and cooled, that symmetry broke like water freezing into ice crystals. One of the most critical breaks was between matter and antimatter. Physics suggests they should have been created in equal amounts, annihilating each other into pure energy. Yet a tiny asymmetry, a 1 in a billion preference for matter, left behind the stuff of galaxies and life. Without that broken symmetry, nothing material would exist. Every snowflake begins with hexagonal symmetry, but the unique path it takes through the atmosphere, encountering varying humidity and temperature, breaks that perfect template in a unique way, creating its one-of-a-kind design. This is the cosmic blueprint's brilliant strategy. It establishes a fundamental, elegant symmetry as a starting point, a set of perfect rules. Then, through the unfolding of events and the influence of the environment, that symmetry breaks in specific ways, giving rise to all the diversity and structure we cherish. Symmetry provides the stable foundation, and broken symmetry writes the unique, evolving story. It is the interplay of these 2 forces, perfect order and creative imperfection, that paints the detailed masterpiece of our cosmos. And when these balanced forces are set into motion, they create another universal spectacle, one of beautiful, chaotic flow. A raging river churns with what seems like pure, untamed chaos. Yet within that furious, foaming water, a hidden geometry is at work. This is the domain of turbulence, and it holds one of the universe's most surprising secrets, that even its wildest disorder follows a pattern. For centuries, the erratic dance of smoke from a candle or the violent eddies in a storm seemed the very definition of randomness, a place where prediction broke down. But chaos theory, a revolutionary field of mathematics, changed our view entirely. It revealed that these systems are not random at all. They are deterministic, meaning their future is entirely set by their starting conditions and the laws of physics. The catch is, they are so exquisitely sensitive that the tiniest, immeasurable difference in the beginning leads to a vastly different outcome, the famous butterfly effect. Within this apparent unpredictability lies a hidden shape, a strange attractor. Imagine plotting the state of a chaotic system, like a double pendulum swinging wildly over millions of cycles. Instead of filling the graph with a random scatter, the points coalesce into an intricate, beautiful structure with a fractal dimension, a shape of infinite complexity confined within a boundary. This is the strange attractor, the ghostly skeleton of order within the chaos. It is the pattern the chaos keeps returning to, even though it never repeats the same path twice. We see this signature everywhere energy flows vigorously. Jupiter's great red spot is a titanic, self-sustaining storm, a vortex of turbulence that has persisted for centuries within the even more turbulent bands of the gas giant's atmosphere. The roiling clouds of the interstellar medium where stars are born churn with turbulent motions on a galactic scale. Even the airflow over an airplane wing, which must be carefully managed for lift, transitions from smooth laminar flow into a turbulent boundary layer, a complex dance of tiny vortices that actually helps keep the airflow attached to the wing. Turbulence, then, is not the absence of order. It is a highly complex, mathematically describable state that many systems naturally evolve toward when energy and flow reach a certain threshold. It represents a universal solution for dissipating energy efficiently through a cascade of motion, from large eddies down to vanishingly small ones. This tells us something profound about the cosmic blueprint. It is not a recipe only for perfect crystals and serene orbits. It has a full chapter dedicated to dynamic, far from equilibrium complexity. The universe's patterns include both the stillness of a hexagon and the beautiful, untamable storm. This reveals a cosmos capable of infinite creative expression, from the most stable symmetry to the most inventive chaos. And this creative impulse did not stop with nature, it sparked within us. Our ability to see this order leads to a startling, almost circular truth. We are here pondering the spiral of a galaxy and the branching of a tree, precisely because the universe permits such intricate beauty to exist. This observation is at the heart of what philosophers and scientists call the Anthropic Principle. It is a simple yet deeply resonant idea. The fundamental constants of nature, the strength of gravity, the charge of an electron, seem almost miraculously tuned. If any one of them were slightly different, the cosmic story would have ended almost before it began. Stars would not have ignited, complex atoms would never have formed, and the elegant, repeating patterns we marvel at would have no stage upon which to appear. In a cosmos with even marginally different rules, there would be no spirals, no fractals, no observers to notice their absence. This fine-tuning is not a proof of design, but it is an undeniable feature of our reality that demands an explanation. It raises questions that sit at the boundary of science and philosophy. Is our universe a singular, incredibly fortunate accident, a one in a trillion roll of the cosmic dice that happened to produce a world rich with pattern and life? Or does it suggest a vast multiverse, an infinite sea of universes, each with its own random set of physical laws? In such a landscape, we would inevitably find ourselves in one of the rare bubbles where the numbers align just right for complexity to arise. The Anthropic Principle does not answer these questions, but it frames them. It reminds us that our very existence as conscious observers is a filter through which we perceive reality. We do not see a random, barren cosmos. We see a cosmos capable of generating the patterns that led to us. We are not separate from the blueprint. We are its most intricate expression, a pattern of consciousness that emerged from billions of years of patterned evolution. This is a profoundly reflective turn. It means our quest to understand the universe's order is not a detached analysis. It is the universe, in a sense, becoming aware of itself. Our curiosity, our drive to find the code, is woven into the fabric of the very system we are trying to decode. This interconnectedness does not diminish the scientific pursuit, it deepens it. It invites us to consider our place not as outsiders looking in, but as active participants within a grand, self-revealing design. The patterns are not just out there, they are in here, in the minds that perceive them and the questions we ask. A single tree stands as a living library of the universal code. Its trunk rises and branches into a fractal network, reaching for sunlight and rain. Each of its leaves is attached by a slender stem in a precise spiral arrangement around the twig, a pattern called phyllotaxis that ensures no leaf shades another. And this entire living structure breathes in a steady rhythm, drawing water from the earth in a daily cycle, shedding its leaves in an annual one, and participating in the grand carbon cycle of the planet. This is not just a tree, it is a conversation between patterns, a place where branching, spirals, and cycles meet and collaborate to create a resilient, thriving whole. This beautiful convergence is the true nature of the cosmic blueprint. The individual signatures we have decoded do not exist in isolation. They are threads in a vast, interwoven tapestry, constantly interacting and nesting within one another to generate the breathtaking complexity we call reality. Look up at the spiral of a galaxy. It is not a solitary island in the void. That majestic whirlpool of stars is itself a node within a greater branching structure, the filamentary cosmic web that connects all galaxies across the universe. And that galaxy has its own life cycle. It is born from collapsing gas, matures by forging generations of stars, and may eventually collide with others or fade, its material recycled into new celestial structures. The spiral, the branch, and the cycle are all present, operating at a single, colossal scale. This nesting of patterns repeats everywhere. Your own circulatory system is a branching network, but the flow within it is a rhythmic, pulsing cycle. The chambers of your heart may even echo a spiral form in their muscular arrangement. A hurricane is a spiral storm born from the cyclical heating of the ocean, and its power dissipates through turbulent, branching patterns of rain bands. This profound interconnectedness is the core lesson of fields like ecology and systems theory. A forest is not merely a collection of individual trees. It is a dynamic network, a web of relationships. The trees communicate through fungal networks in the soil. Animals disperse seeds along branching paths of migration. Nutrients cycle from soil to leaf to decomposer and back again. Every organism, every pattern, exists in relation to others, and the health of the whole system depends on these intricate connections. To understand a forest, or a galaxy, or a cell, we must shift our perspective. We must move from cataloging the individual parts to appreciating the dynamic whole, the system. The blueprint, then, is not a stamp that repeats a shape. It is more like a set of relational rules, a grammar for how patterns combine, interact, and give rise to ever more complex and stable structures. When we begin to see the world through this lens, everything changes. An environmental scientist no longer sees a polluted river as an isolated problem, but as a symptom of a broken cycle within a larger watershed system. A doctor understands that healing is not just about treating a single organ, but about supporting the intricate, cyclical networks of the entire body. And for each of us, it reframes our place in the cosmos. We are not passive observers standing outside a mechanical universe. We are active participants within a living, breathing, patterned whole. Our minds, which seek and create patterns, are themselves a product of this deeply interconnected reality. Recognizing this invites a deeper humility and a greater sense of belonging. If every pattern is connected, then the spiral in the galaxy, the branching of the river, and the cycle of your breath are all expressions of the same coherent story. This holistic view leaves us with one final, inevitable question. If all these patterns are so beautifully, logically intertwined, where did the first rule, the original relational grammar, come from in the first place? The origin of the universal blueprint is a question that echoes back through the ages. Science has given us the language to describe these laws and patterns with breathtaking precision, but it remains silent on a deeper mystery. Why do these laws exist at all? And why are they precisely the kind that give rise to galaxies, sunflowers, and minds capable of wondering about them? For science, the laws of physics are the ultimate starting point, the brute facts of a self-contained cosmos. They simply are, but the human spirit is restless with that answer, sensing a deeper layer to the mystery. One compelling perspective comes from the edge of theoretical physics, known as the mathematical universe hypothesis. It proposes a radical idea. What if mathematics is not merely a tool we invented to describe reality, but is reality itself? In this view, the cosmos is not a physical thing that happens to follow mathematical rules. It is, at its core, a mathematical structure. Our perception of a physical universe with stars and atoms and forces is a kind of shadow or interpretation of that deeper, abstract reality. The patterns we see, from the Fibonacci sequence in a pine cone to the equations of general relativity, are not approximations. They are direct glimpses into the true, timeless fabric of existence. This idea suggests that the blueprint is not written in the language of physics, but that physics is written in the language of the blueprint. Throughout history, philosophical and spiritual traditions have approached this same mystery from a different angle. Many have spoken of a cosmic mind, a universal reason, or a logos, an ordering principle that imbues the cosmos with meaning and form. In these views, the elegant, discoverable laws are not accidental, but reflective of a foundational intelligence or creative intent. Whether one sees this as a metaphor for the universe's inherent order or as a literal description, it addresses the same profound intuition. The fact that the universe is not chaotic, but is instead governed by a coherent, beautiful, and intelligible logic feels significant. It feels like a signal, not just noise. This question of origin sits at the ultimate frontier where empirical science meets metaphysics. We may never have a definitive, testable answer that satisfies every seeker. Yet, the very fact that we can ask the question, that we can perceive a blueprint and debate its source, is perhaps the most important clue of all. It means we are participants in a cosmos that generates not just patterns, but pattern seekers. Our drive to understand is itself a product of the very order we are trying to understand. Regardless of where one believes the blueprint originates, its existence has immense practical power for our lives right now. Recognizing these universal patterns changes how we see the world. A city planner can design more resilient communities by understanding the efficient, branching patterns of natural networks. An engineer can create stronger materials by mimicking the hexagonal structures found in honeycombs. An artist can tap into a deep well of aesthetic resonance by employing the golden ratio or fractal complexity. When we align our creations with these timeless forms, we are not just making things, we are collaborating with a deeper current of reality, building in harmony with principles that have shaped the universe for billions of years. This practical wisdom, born from cosmic observation, invites us to become more conscious co-creators within the grand, patterned whole. The most brilliant designs are often not our own. For millennia, humanity has looked to the natural world not just for resources but for instruction. We have long copied the efficient patterns around us, a practice now formalized as the science of biomimicry. This is more than simple imitation. It is a profound act of listening. It is the conscious decision to learn from a master engineer who has had billions of years to run experiments. Consider the Shinkansen bullet train in Japan. For years, its thunderous sonic booms when exiting tunnels were a major problem. Engineers found their solution not in a wind tunnel, but by studying a bird. The kingfisher dives from air into water with barely a splash, its beak perfectly streamlined to transition between mediums. By reshaping the train's nose to mimic that elegant curve, they eliminated the boom, reduced noise, and increased speed and energy efficiency. The blueprint for a quieter, faster train was written in the anatomy of a bird. Look at the arrangement of solar panels in some cutting-edge power plants. They are not laid out in simple rows. Instead, they are arranged in a precise spiral pattern, mirroring the seed head of a sunflower. This phyllotaxis arrangement, governed by the golden ratio, ensures each panel minimizes shadow on the next throughout the day, capturing significantly more sunlight with the same number of panels. Even the humblebird, that stubborn hitchhiker on a dog's fur, inspired Velcro. Its tiny hooks catching on loops became a model for a revolutionary fastening system. These are not random acts of copying. They are deliberate applications of patterns that have been refined by evolution, which is itself the universe's algorithm for finding optimal solutions within the laws of physics. When we engage in biomimicry, we are tapping directly into the cosmic blueprint. We are acknowledging that nature, through endless iteration and selection, has already discovered the most elegant, sustainable, and resilient answers to many of our own engineering challenges. This approach moves us from fighting against natural principles to working with them. It leads to technologies that use less material, consume less energy, and integrate seamlessly into the systems of our world. Biomimicry transforms the universal patterns from a beautiful observation into a practical toolkit, proving the blueprint is a source of immense, untapped wisdom. This same wisdom, this resonance with foundational forms, has been guiding human hands in a different way for just as long, shaping the spaces we inhabit and the art that moves us. The vaulted ceiling of a Gothic cathedral is a stone forest of branching ribs, each smaller arch echoing the form of the great one that supports it. This is not mere decoration, it is architecture in conversation with the cosmos. For centuries, long before the word fractal was coined, builders were weaving recursive patterns into stone and glass. Those soaring cathedrals used the repetitive geometry of pointed arches to distribute immense weight gracefully, creating a sense of awe that feels both human and divine. The design seems to grow organically, with smaller forms nestled within larger ones, mirroring the self-similar branching of a tree or the nested structure of the cosmic web. This intuitive grasp of universal patterns extends far beyond medieval Europe. Consider the geodesic dome, a structure of breathtaking efficiency pioneered by Buckminster Fuller. By tessellating the surface with a network of triangles, the dome achieves remarkable strength using minimal material, a direct echo of the molecular architecture found in crystals and even the spherical shells of certain viruses. It is the Hexagon's principle of efficient packing, scaled up to shelter human beings. In the visual arts, few explored this territory more deeply than M. C. Escher. His mesmerizing prints of tessellating fish, birds, and reptiles playing with impossible staircases and endless loops are direct meditations on infinity, symmetry, and the recursive patterns of fractal geometry. He gave visual form to the abstract mathematical beauty that underpins reality. And what of music? The very scales we find pleasing are built on precise mathematical ratios. An octave represents a 2-to-1 frequency ratio. The harmonious sound of a perfect fifth corresponds to a 3-to-2 ratio. Rhythm itself is a temporal pattern, a cycle of beats that can syncopate and branch into complex polyrhythms, creating a sonic architecture that moves our emotions. Why does a Bach fugue or the spiraling melody of a symphony feel so profoundly satisfying? Because it is built from the same relational logic, the same interplay of repetition and variation, that structures a spiral galaxy or the growth of a nautilus shell. This human creativity is not inventing something entirely new. It is tapping into a deep wellspring of order, discovering and playing with the same fundamental forms that the universe uses to build itself. When we create a work that employs these patterns, we are not just making art or engineering. We are aligning our expression with the grammar of reality. The resulting harmony we feel is a resonance, a recognition on a level deeper than intellect. We are creatures born of this patterned cosmos, so we naturally find beauty and meaning in its signature forms. Our built environment, from the humblest woven basket to the most ambitious skyscraper, can become a conscious dialogue with the cosmic blueprint. This dialogue has always pointed our gaze earthward, but now it beckons us to look outward, to imagine how these timeless patterns might shape the very future of human existence beyond our home planet. The principles that built our world will be the same ones that allow us to build new ones. As we turn our ambitions toward the stars, the cosmic blueprint shifts from a fascinating observation to an essential survival manual. The immense challenges of living on Mars or in the void of orbital space are not just engineering problems, they are tests of our ability to align with universal patterns. Consider the habitat. On a world with minimal atmosphere and intense radiation, every gram of material and every joule of energy is precious. The hexagonal pattern, nature's masterclass in efficient packing and structural strength, offers a compelling model. Imagine modular living quarters, research labs, and greenhouses tessellating together like a colossal honeycomb, sharing walls for maximum radiation shielding and structural integrity, while minimizing the mass we must launch from Earth. This is not science fiction, it is biomimicry at a planetary scale, applying a billion-year-old design solution to a new frontier. But a shelter is not enough. To survive, we must create a miniature, self-sustaining biosphere. This is where the pattern of the cycle becomes a matter of life and death. Our life support systems cannot be linear, using resources once and discarding waste. They must be closed loops, elegant cycles that mirror Earth's own grand processes. Wastewater must be purified and returned to the system. Exhaled carbon dioxide must be captured and fed to plants, which in turn produce oxygen and food. Every output must become an input, creating a rhythmic, circular flow of matter and energy. This is the blueprint of ecology, and mastering it in a sealed canister is the key to lasting beyond our home planet. Even our energy strategies can learn from the stars themselves. The process of nuclear fusion that powers our sun represents the ultimate expression of matter converting to energy under extreme conditions. While we strive to replicate that clean power on Earth, understanding the broader stellar pattern, the birth, life, and death of stars that forge and distribute the elements, teaches us about the very resources available to us. Asteroids, the leftover debris from planetary formation, are not random rocks. They are archives of the solar system's construction, often rich in metals and water ice. By recognizing the patterns of planetary accretion, we can better locate and utilize these celestial resources, turning potential hazards into the building blocks and fuel depots for our journeys. This application extends to our search for other homes. When astronomers scan the heavens for habitable exoplanets, they are not looking at random dots of light. They are looking for signatures that fit a known pattern. They seek worlds orbiting within the temperate Goldilocks zone of their star, where liquid water can exist in a stable cycle. They analyze atmospheric compositions for the chemical balances that, on Earth, are maintained by the interconnected cycles of life. The blueprint gives us a filter, a set of cosmic criteria for where life, and perhaps a future for humanity, might successfully take root. Ultimately, this is the profound lesson the blueprint holds for our future. It provides a universal set of principles for sustainable existence in any environment: efficiency through optimal form, resilience through interconnected networks, and longevity through closed, regenerative cycles. To become a spacefaring civilization is not to conquer the void, but to learn to listen to it and build in harmony with its inherent logic. Our survival out there may depend less on forcing our will upon alien landscapes and more on our humility to read and apply the design manual that the universe has been writing since the beginning. This forward leap brings with it a weighty and inescapable question, a responsibility that comes from finally understanding our place within the patterned whole. Our recognition of the cosmic blueprint carries a profound responsibility. When we see the world as a web of interdependent patterns, our role within it shifts dramatically. We are no longer just clever visitors extracting resources from a passive environment. We are active, conscious threads woven into a living tapestry, and every action we take sends vibrations through the entire network. The environmental challenges we face today are not random misfortunes. They are direct, predictable results of operating against the grain of the universal patterns we have been exploring. We disrupted the carbon cycle by releasing ancient stored carbon faster than natural systems can reabsorb it. We simplified branching, resilient ecosystems into monocultures, making them fragile. We designed linear economies that take, make, and waste, ignoring the cyclical wisdom that sustains all complex systems. These are not just policy failures, they are a fundamental misreading of the cosmic instruction manual. The resulting climate shifts, loss of biodiversity, and pollution are the cosmos feedback, a clear signal that we have violated its foundational principles of balance, efficiency, and connection. This understanding points toward a new ethical stance, one not of domination, but of stewardship. It is an ethics born of humility, recognizing that our intelligence does not exempt us from the laws that govern galaxies and forests. Instead, it obligates us to use that intelligence to align our societies, our economies, and our technologies with the sustainable, beautiful, and efficient patterns that allowed complexity and us to arise in the first place. This means designing cities that function like ecosystems with circular flows of energy and materials. It means creating economies that value regeneration over endless extraction, mirroring the endless cycles of nature. It means measuring progress not by how much we consume, but by how well we integrate into and enhance the living patterns around us. This perspective fosters something greater than environmentalism. It fosters cosmic citizenship. Caring for a local watershed or protecting a species is not just a local act. It is an act of honoring the same blueprint that shaped spiral nebulae and the double helix. It is acknowledging that the principles of connection and care are written into the fabric of reality itself, and to violate them is to work against the very current of creation. This ethical dimension completes our journey from passive observation to active, meaningful participation. We began by marveling at patterns, and we arrive at a call to embody them. Yet, whenever a grand, unifying idea like this is presented, thoughtful skepticism is not just welcome, it is essential. Some will rightly question whether we are seeing true cosmic order or simply projecting our own human love of pattern onto a random universe. Skepticism is the necessary guardian at the gate of any grand idea. The mind that sees a face in the clouds can just as easily see a cosmic design in a seashell. This is a crucial and valid challenge. Are we connecting dots that were never meant to be connected, mistaking poetic metaphor for physical law? The answer lies not in dismissing the question, but in the tools we use to answer it. The human brain is indeed a master of apophenia, finding meaningful shapes in randomness, but science provides the corrective lens. It does not rely on vague visual resemblances. It demands mathematical rigor and predictive power. The spiral of a hurricane and the spiral of a galaxy are not just similar-looking curves. They are both described by the same precise equations of fluid dynamics, the mathematics of vorticity and angular momentum. The prediction is clear. Given a rotating, contracting fluid, a spiral will form, whether that fluid is air or interstellar gas. This is not an analogy. It is an identical physical solution to an identical physical problem. In biology, convergent evolution is not a just-so story. It is a documented pattern in the fossil record and genetic code, showing how unrelated lineages, facing the same environmental pressures, independently arrive at nearly identical anatomical solutions, like the streamlined bodies of sharks and dolphins. Science distinguishes true signal from noise through controlled observation, repeatable experiment, and, most importantly, mathematics. The fractal dimension of a coastline can be calculated, not just admired. The branching angles of a tree can be modeled by algorithms that maximize sunlight capture. When a simple mathematical rule generates the intricate pattern of a fern leaf or the distribution of galaxies, we are witnessing more than coincidence. We are reading the source code. The elegance of this is breathtaking. The fact that a staggeringly complex universe can arise from a surprisingly small set of simple, elegant laws is not a flaw in the argument. It is its greatest strength. It points to a cosmos built on principles of efficiency and parsimony, where maximum richness emerges from minimal instruction. This critical perspective does not weaken the idea of a cosmic blueprint. It refines and strengthens it. It moves us from a sense of vague wonder to a grounded appreciation of a deeply logical and mathematically articulate reality. So, having confronted the doubts, what emerges is a clearer, more robust picture, one that invites a fundamental shift in how we perceive our place within this grand, patterned whole. The old story of the cosmos was one of machinery, a great clock wound at the beginning and slowly, inevitably, winding down toward a cold and silent end. But the blueprint we have been tracing tells a different story entirely, a story not of a machine, but of something far more alive. It reveals a universe that is less like a ticking clock and more like a growing, unfolding organism, expressing its inherent potentials through an endless dance of creative, repeating forms. This is a narrative of unfolding complexity, where each new level of organization sets the stage for the next, from quantum fields to conscious minds. The patterns are not static cogs in a predetermined wheel. They are dynamic, relational, and deeply interconnected. They suggest a cosmos with a kind of innate creativity, a capacity to generate novelty and beauty within the stable framework of its own laws. This shift in perspective is profound. It moves us from seeing ourselves as accidental tourists in a random, meaningless void, to recognizing ourselves as conscious nodes within a vast, self-patterning network. We are not separate from the universe looking in. We are the universe looking out, a localized expression of its own capacity for awareness. This new cosmic story offers something the cold, mechanical model often lacked, a scientifically informed sense of meaning. Our human drive to explore, to create, to understand the spiral in the shell and the law in the stars is not a fluke. It is the cosmos becoming aware of its own design. Our curiosity is the universe's curiosity. Our art is the universe playing with its own forms. Our science is the universe decoding its own source code. This perspective does not require a designer in the traditional sense, but it does reveal a cosmos pregnant with potential, a reality where the emergence of life and mind feels less like a bizarre accident and more like a natural, though wondrous, flowering of inherent possibilities. It fosters a deep sense of belonging, of being woven into the very fabric of existence. We belong here not as owners but as participants. This sense of connection can inspire not just awe but a renewed responsibility. It invites us to align our own creations, our societies and technologies with the elegant, sustainable patterns that have allowed this grand story to unfold for 14 billion years. To honor the blueprint is to honor the story itself and our unique role within it. This brings us to a final, integrative view, a way of seeing that ties every thread together into a single, breathtaking tapestry. The tapestry is complete, and the picture it reveals is one of profound, creative unity. We have traced the spiral from the galactic whirlpool to the chambered shell, followed the branching network from the cosmic web to the veins in a leaf, and felt the pulse of cycles from the orbit of a planet to the rhythm of a heartbeat. Each thread on its own is a marvel of logic, but woven together they form a portrait of a cosmos that behaves less like a cold machine and more like a master artisan. This artisan does not work with chisel or brush, but with the immutable tools of mathematics and physics. Its studio is the vacuum of space, its materials are quantum fields and fundamental forces, and its technique is the relentless, elegant application of a simple set of rules. Every spiral galaxy is a stroke from this brush, every snowflake a signature of its method, every beating heart a testament to its creative potential. The universe crafts not with conscious intention as we understand it, but with the inevitable, beautiful logic of its own existence. The patterns we admire are the finished artwork, and the laws of nature are the refined technique honed over 14 billion years. Whether this grand creative process has a purpose, a final masterpiece in mind, is a mystery that may forever lie beyond our reach. Yet, the beauty and coherence of the result are undeniable facts of our reality. This synthesis places us in a remarkable position. We are simultaneously the artwork and the artists. We are structures assembled by these universal patterns, our very bodies and minds built from their logic. And yet, within us, these patterns have given rise to something new, the capacity to perceive, to admire, and to replicate the design. We are the universe's way of appreciating its own handiwork. This perspective transforms our relationship with the cosmos. It is no longer a foreign, indifferent void we gaze upon with lonely wonder. It is a home filled with a familiar, elegant design. The same grammar that writes the story of a star writes the story of a cell. The same geometry that structures a honeycomb structures the storm on a gas giant. This recognition fosters a deep, intuitive belonging. We are not visitors in this universe, we are expressions of it. Our curiosity to understand the spiral is the universe seeking to understand itself. Our drive to create beauty is the universe continuing its craft through our hands. With this holistic view, the separation between observer and observed dissolves into a relationship of participation. We are invited to see not just the patterns around us, but to recognize the pattern within us, and to move through the world with the quiet understanding that we are walking, talking, wandering pieces of a magnificent and coherent whole. This cosmic song of patterns is an invitation to see reality with new eyes. We have journeyed from the spiral arms of galaxies to the spiral within our own cells, from the branching of rivers to the branching of our thoughts. Each repetition is a whisper from the fundamental laws of physics, a simple set of rules playing out with infinite patience across every scale of existence. The universe is not a collection of random events, but a coherent story written in the language of geometry, mathematics, and relationship. This realization does more than satisfy our curiosity. It transforms our place within the narrative. Our awe is no longer passive wonder, but an engaged recognition. We see that the efficiency of a honeycomb can inspire stronger materials, that the closed loops of a natural ecosystem provide the model for sustainable cities, and that the fractal resilience of a forest can teach us how to build more robust communities. Understanding the blueprint is a call to align our own creations with the timeless wisdom written into the fabric of everything. We are not separate from this grand design, we are a vibrant part of it. As the astronomer Carl Sagan beautifully observed, we are a way for the cosmos to know itself. When we learn to read these universal patterns, we participate in that profound act of self-knowing. We become conscious collaborators in a story 14 billion years in the making. So I leave you with this simple invitation. Step outside today. Look at the curl of a fern, the structure of a pine cone, or the path of a stream. See them not as isolated objects, but as verses in a cosmic poem. Notice the patterns, feel the connections, and carry that new vision with you. In the comments below, I would love to hear what pattern in nature you find most captivating or mysterious. And if you want to continue exploring the wonders of our universe, be sure to subscribe for more journeys into the unknown. Thank you.